Let's begin by looking at some basic concepts of magnetism. The first magnets people used were natural magnets called lodestones that were formed by lightning strikes into the earth and by meteorites that fell to earth. Early explorers used lodestones to navigate. A floating lodestone would always point toward the north. What is this magnetism that the early lodestones possessed? At its most basic, magnetism is an invisible force field that surrounds particular objects. This field then attracts certain materials. A magnetic field is made up of thousands of invisible lines of force called flux lines that extend out from the magnet. You can see these flux lines by conducting a simple experiment using a common manufactured magnet and some small iron filings. As you will soon see, iron is strongly affected by the magnetic flux lines that surround magnets, like this one. When the filings are sprinkled over the magnetic field, they become attracted to the flux lines. These filings follow the exact shape and path of the flux lines. The concentration of these flux lines defines the strength of the magnetic field. The concentration of the lines next to each other is called the flux density of the magnetic field. The more lines in one area, the greater the flux density. The greater the flux density, the greater the concentration of magnetic force. If a stronger magnet is used and the procedure is repeated, the iron filings are drawn closer together. This closeness indicates the flux density has increased. Notice that the lines are parallel. Flux lines never cross one another. Flux lines always form complete loops around a magnet. They leave one end of the magnet and flow into the other end of the magnet. The ends of a magnet are its north and south poles. The poles of a magnet are where the flux lines come together, or are concentrated. The flux lines flow out from the North Pole and return to the magnet at the South Pole. The North Pole of one magnet and the South Pole of another magnet are attracted toward each other. At the same time, North Poles of magnets repel each other, and South Poles of magnets repel each other. This is another statement of Coulomb's law that works for magnetism just as it works for electricity. Opposite poles attract, and like poles repel.